Okay, this is 4.8 homework. I'm going to try to give you a little less information in this homework help video and let you try to solve these on your own because this is all stuff you can do. It's just application, and it's going to be hard to read and convert and draw a picture, but I'll help you set up those at least. So the first problem then gives us the diameter of the moon and the average distance from the Earth, and it says that we're looking for the angle that subtends that. So let's say we're on the Earth here, and I know technically, you know, we're on the Earth here, and then the moon's over here, and we're looking for this angle. Draw this a different color. We're looking for this angle right here. Okay, so what we're going to do for that is they give us the diameter. We're going to draw a line straight to the center of the moon right there so we can make a right triangle. It says that this is 236,000 miles, and it says that this is 2,160, so we're going to cut them in half and make this 1,080. So we have a right triangle then. Check your units, we're in miles, so that works, and we can find this angle just by doing inverse tangent. So tangent of theta equals opposite over adjacent. Do inverse tangent of this, and that gives you, so your theta, if you do inverse, gives you 15.73 approximately. And by the way, that's after you multiply by 60, because, right, actually what you get is 0.262, you got to multiply that by 60 in order to get this, because there's 60 minutes in a degree. So to get it into minutes, you do this, which is what they want. They want minutes. And then you have to double it as well, because you want both of these angles here to make up a full one. So you end up with like 30 point something. Or I do anyway. 31.46. I don't know if your numbers are different. Just do the same thing for the sun then, here, the next one. And actually the next problem is similar as well. You have this big star with a diameter of 200 million miles, which is huge. And we're looking at this thing from a long ways away on Earth here. And so we're going to set up the same picture. And we're going to do the same exact thing where this is now 3 times 10 to the 15th miles. This is 100 million then. It's half the diameter. Or 1 times 10 to the 8th, I guess I could have did. Make it a little easier. Scientific notation for both. And then it wants this angle right here. So we're going to have to find the little one and then double it again. And so obviously it's the same thing, inverse tangent, you know, to find the angle like we did last time, and then double it to find the whole thing. The next question then becomes, I end up getting about 0.0138. Keep in mind you're going to need to multiply by 3600 when you get this angle, because you got to convert it to seconds from degrees, and it says that right here. And then we're going to put a penny out here somewhere. I know I've drawn this really big, and it's not the scale obviously, but we're going to put a penny in here, and obviously these are similar triangles now, right? Because we want the same angle. So it gives us that the diameter of a penny is about 0.75 inches. That's this whole distance though. I want half of that, so I'm going to do 3/4 times 1/2, which is 3/8. So it's 3/8 of an inch right here, this distance right there. But I also need to convert that to miles, because we're in the units of miles here, and the question asks how many miles do I end up. So to convert that to miles, the 1 foot is equivalent to 12 inches. So you're going to divide by 12, and then you're going to divide by 5,280 feet, or in 1 mile. So you're going to end up dividing by 12, 3/8 divided by 12, and then divide that by 5,280 to find this distance here in miles. And then use this triangle right here, a little hard to see, so I'll redraw it for you, where this number right here goes here, whatever this is, and this distance is what you're trying to find, knowing that this angle is 0.0138 seconds. So you're gonna, I would use that degree measure that you get in your calculator. It'll already be stored in your calculator. And then just do opposite over adjacent. So do tangent of this angle equals this number, whatever it is, divided by x, and solve that way. Okay, the next question is a hard one to set up as well. you have a river that's flowing north like this, and you start off here. And when you start off, you notice this tree on the other side that's at an angle of 30 degrees with horizontal. So this would be like a 30-degree angle here. And you walk forward 100 feet until you get to this new spot where the new angle is now 45 degrees. So if you want to look at that, the question is then, you reach a cliff right here, so the question becomes, how wide is the river? Well, I can make a right triangle from here, and that's what I'm looking for. I call that X. So let me redraw this picture over here for you. Here's 30, here's 45. I know this isn't a very good drawing, but this is 100. So this is basically the picture that you end up setting up. It's a right angle, and you're looking for that value X. What I did is I did the law of sines first, so I did sine of 30 over, I'll call this Y, equals, this angle is 135 then, which makes this angle 15. So I do sine of 15 over 100, if you remember the law of sines. And that allows me to solve for Y. And once I get Y, then I can do, the sine of 45 equals opposite over hypotenuse. So sine of 45 equals opposite X over hypotenuse Y, which I'll now have Y. So that's how I found X, which is the distance across. I ended up getting 136.6, but your numbers might be different. Okay, the next problem says you approach a hill, and there's a tall radio antenna, so I'm going to draw a really rough picture of this, but you've got this antenna, put a little flag on top or something, I don't know. And so you approach this, and you were 600 feet away, and it says the angle to the bottom is 10 degrees, and the angle to the top is 25 degrees. So you kind of got to look at two right triangles here. So to find the height to the bottom, that's tangent of 10 degrees equals opposite, I'll call that X, over adjacent, 600, multiply both sides by 600. That allows you to find the bottom of the antenna. And then to find this distance, we'll call that Y. You're going to do tangent of 25 equals opposite Y over 600. Multiply both sides by 600. That gives you Y. Don't forget to, when you find Y, subtract X to find the height of the antenna. That's the actual height of the antenna. All right, the next problem, then I'll just set up a picture for you and kind of tell you how to do it and let you solve it. You can ask me in class if you get stuck, but if this is 20 here and this is 17 as these angles of depression, this would be 3 degrees. And then also, if this angle here is 17, this angle is 17 because they're actually alternate interior angles, two parallel lines cut by a transversal. And then from there, you know this angle as well then. This angle would be 160. And so you can use the law of sines, for example, again. Like the sine of I would actually do the sine of 17 over its opposite side, call this like Y, equals this sine of the angle which is 3 over this side opposite that is 1 mile. So if you solve this proportion, you'll get this distance of this triangle in miles. And then you can find, this is a right angle. And this is 70, for example, and this is 20, because, well, once again, alternate interior angles here and here. Or if this is 20, this is a right angle here. So either way, that's 70, that's 20, and know this side, so you can do, take either one of these angles. If you use this angle, you do opposite over hypotenuse. If you use this one, you'll do adjacent over hypotenuse to find the height. All right, the next problem then, here's the picture you can set up. If you're flying in a plane and you notice an angle of depression of 17 degrees to this airport, and then you're at a height of 26,000, you can easily find this distance in this triangle by setting up this right triangle. Obviously, if this is 17, then you can find this angle, and I think you guys can solve that one as well.